Thanks so much. Good to see all you this morning. My daughter and I do not talk about data science at dinner, but I will tell you that she is speaking at another data science conference in a big city in the United States right now as we speak. So we kind of have this like little gig going on. Maybe we should just start a data science speaking business. My background is eclectic. I've done things in software engineer. I was one of those software engineers who was the person who was in a cube going, why are we building this anyways? So I sort of got booted out of software engineering and ended up in product management and program management, eventually in marketing, as my husband says, the dark side of the world. And then back a number of years ago, I landed at Nokia, back in the early days of really big data. In 2010, where Nokia obviously had a whole bunch of interesting challenges. And I built and ran the big data team there and was using the Hadoop technology in the very early days, ended up being a Cloudera customer, did a whole bunch of things. Nokia went through, obviously, some really amazingly changing times. An incredible company that's 150 years old that has transformed themselves drastically every few decades from being, like they actually used to mill trees on the banks of rivers in Helsinki, and then became a rubber manufacturer and eventually consumer electronics, and then built the first cellular network in the world in Finland, and then went on to become the world's largest mobile phone provider, then sort of missed that little smartphone thing, and reinvented themselves and are now one of the top 3 network equipment companies in the world. So it was a really interesting time at Nokia to go through analysis of a lot of big data sets. But I think the biggest thing that I learned there was the people side of the equation. How do you put people together when you have you have all this data and you have new and disruptive technology that works very differently? And how do you get people who, many of them have been in the IT industry for a few decades, to change how they work together? So that's some of what I'm going to talk about today. I joined Cloudera about 5 years ago now, and I put 1 million miles on the road in those first 4 years, just going around the world talking to customers about how do you organize, how do you find skill sets, how do you put people together to really take advantage of some of these new tools. You know, I say, the technology's hard, let's face it, it's hard, but I always say it's the people that's the most difficult part. You know, we can figure out the technology, but how do you actually get people to do things differently? So now, I have a really interesting job now. I am focused inside our company, helping our own company to use our own products and data to run our company better. And I must say there's many days where I feel like that. You know, the cobbler's children have no shoes. You know, inside the company that builds this cloud-based big data and analytics platform that many companies around the world use, we sort of have our own people problems. So those are interesting as well. So I'm going to talk a little bit about this center of excellence problem and then that special sauce of people. But I wanted to sort of start with the Simon Sinek's whole, like, you know, the why, the how, and the what. So like, why do we even care, and why do we spend our days and, quite frankly, a lot of our nights thinking about this stuff and building new things? And it's really because data and analytics and machine learning and getting towards more artificial intelligence, I still see the world much more sort of in the machine learning space, so the application that will lead towards more artificial intelligence. And it's really because we're going to be able to do things that we never were able to do in the past. And Sandy talked about some really interesting things about being able to leverage data sets that are encrypted, and, you know, sort of even more future things. I'm still looking at the inside of the enterprise for the most part. So here's a couple of examples. The Orion spacecraft mission, which is still on, where the intent is to eventually get people to the surface of Mars, is instrumented with a whole bunch of sensors. And they did, a couple years ago in 2014, they did 2 orbits around the Earth at about 20,000 miles per hour, 3,600 miles above the Earth's surface. And that spacecraft is instrumented with a whole bunch of sensors. The whole point of that is to really get an understanding as to the environment on the spacecraft so that we can ensure eventually when we do put people on that, and the dates, you know, it depends upon sort of who's in office and what the budgets are at certain points in time, but the dates range anywhere from estimates of manned aircraft around 2023 all the way up into the 2030s. And the really big thing there is to ensure as they re-enter the Earth's orbit that they can actually, sustain life. That's a really important thing. So it's not so much getting people out into space, but it's always the most important part is bringing them back. So that's one of the key use cases that I see is about making the impossible possible. I should probably be using my clicker. Making the impossible possible, but my PowerPoint is hung. Excellent, excellent. Now it's not. We'll go back a little bit. You always got to love that. And here's another one. You may recall the Time magazine article back in 2012 where they really exposed this issue with suicide rates in the military. And the military was actually seeing suicides at a rate that was twice that of the US adult population. So pretty significant, terrible issue. And back in 1897, there was a French sociologist who did a bunch of studies on text to kind of see, like, in conversation, could they start to find some predictors of potential suicide disconnection. And a few years ago, there's a company called Patterns and Predictions, and they teamed up with DARPA and with Dartmouth University to start to do natural language processing and figure out if they could help the military with these terrible issues with respect to suicide. So they did first a control group to create their training set of data, and they were able to find enough data in the natural language of doctors' visits and clinical trials to be able to create a model that had 65% accuracy to start to predict suicide indications. And then they moved into the next phase where there was 100,000 vets who opted in to let them use their data, mobile data, Twitter data, social data, clinical data, physicians' data, to test against those models to come up with greater suicide predictions. And they are now in the process of working with the military to roll out better suicide prevention problems. So you kind of see, like, you go all the way from putting people on the Mars down to helping individuals that are struggling with things in a daily life. And it's all based upon being able to use data and machine learning in various different ways. And another example is Komatsu, and I don't know if you can kind of see, I just love the way the little trucks are moving around and moving data and all that. But Komatsu is a company that's headquartered in Tokyo, and they've got a presence in 160 countries around the world, and they make the equipment that moves dirt and minerals and materials both above ground and below ground. And they face a lot of challenges, or their customers face a lot of challenges. First of all, regulatory compliance. There's a lot more things that they need to be aware of. Environmental issues. Just the fact that to mine for minerals, you have to go much deeper and in much more hazardous conditions these days. So there's lots of things that their equipment is exposed to that they weren't exposed to in the past. So Komatsu's done a bunch of work to instrument their equipment, and they do something like they have 5 million events that they track on a daily basis from these fleets that are all over the world. On a daily basis, they actually store 17 billion data points from time series data, and then they run 2 different types of machine learning analysis every second against all these various different machines. And they're looking for anomalies. They're looking for how the equipment is exposed to the environment in different ways so that they can fix things. And some of the fixes that they come up with are, we need a new gearbox in one of these machines that's out there. So they're sort of running their whole business in a very different way than what they were able to do in the past in order to enable their customers to be more efficient. And in this world, more efficiency means a lower cost per ton of whatever it is you happen to be mining. And then MasterCard, I bet it's in your wallet, but MasterCard has a database of hundreds of millions of fraudulent merchants. So not even kind of on the consumer side, but on the merchant side, there's a million inquiries every year from the actual networks that use MasterCard to basically say, I've got another merchant that wants to come on board. Is this a fraudulent merchant? So MasterCard is also using tons of different data from many different signals, many different economic type reports, and then the actual behavioral data of those merchants out in the world to really prevent fraud at the merchant level and then down to the consumer level. So those were just some examples, but I kind of wanted to go into this idea of people who are using data and machine learning, getting towards AI, are actually really much more productive, and their businesses are running at a much greater rate than a lot of the other folks that are out there. So we study the S&P 500. We kind of looked at the top companies, and we found that in the top companies, 5 of them have grown at a rate of 176%. That's their market cap over the course of the past decade. And that's compared, when you actually look at the S&P in general, that's compared to 66% for the S&P in general. And you've seen other reports too. I know there's a great McKinsey study out there about the productivity of companies that use data and machine learning being much higher than that of companies that don't. The other piece of it is just the change in their shares. There's 4% composite value of the S&P 500 in general, and these companies in general have a 14% composite value. So there's some great indicators that focusing in this space of using a lot more data and a lot of analytical methodologies on top of it to find insights into your business is going to have a great economic positive factor on your business. So this is enabled by a bunch of different things. This is the Open Data Science Conference, and one of the key elements underneath in the technology side of the house that's enabled all this is open source. I don't think we would be here today if it weren't for a lot of the major things that have happened in the open source community. If you just start, sort of on the networking side of the house to begin with, and then you move towards Linux and computers and compute and all that, and then out into some of the newer database type worlds today, the things that are based upon Hadoop and the Apache community and a lot of things that are happening there. And then as you move up the stack, there are so many different tool sets and libraries that are available in the open source community to enable people, you and people on your teams, to easily and cost effectively build out new models to analyze data in different ways. So that's one key piece. And then the next key piece is just a lot of those learnings are being put into these machine learning types of tools. So there are things that are available today that weren't even available 6 months ago in the open source community. And then last, there was a little conversation about cloud. And cloud, to me, it's a deployment methodology. It means you have more choice. You have the choice to run things in your own data center, to do hybrid things, to choose across multiple different public clouds or private clouds types of environments. And that's a great way to more easily and quickly be able to bring environments up and get them running, but also decide where does your data naturally gravitate to. Is it being created in the cloud? So maybe that's where you should be doing your analysis. Is it being created on-prem? Are you sharing it with people who are in the cloud? So you have a lot more choices these days with the ability to run a lot of the software that I'm talking about here, the open source software, the Hadoop software, that ecosystem of machine learning tools on-prem and in the cloud. There are just so many different choices. And then the other enabler for us all learning more about our world and everything that we're doing is the fact that so much more data is being created. The first wave of this creation of data was around people talking to people. It was basically chat, the social network connections, really taking a lot of the text-based things that exist in the world today. And that was wave 1. And now we're really, really deeply into that wave 2. Not deeply, I would say we're at the cusp of the wave 2, which is machines talking to machines and starting to see a lot more instrumentation of the world around us so that we can interact with that world in various different ways. So just a quick picture, when I think about sort of where we went from legacy databases where, you had to think about how you were going to use data and figure out what was your schema, put it in there, and people could kind of look at that data and do various different things with it. We now have almost like a Swiss Army knife of tools, of things that sit together. So you can bring your data together. You can do your data engineering on it, the sort of a modern version of ETL where you're ingesting data and getting it available for use by different folks. You can analyze structured data using SQL. You can use tools like Apache Spark to do some machine learning. You can ingest data that's streaming or data that's coming in at batch. And then, quite importantly, you can serve the results of your analytics and your machine learning models out to applications in sort of near real time. So many of the applications that we interact with on our mobile devices on a daily basis, and many of the applications that we interact with on the web on a daily basis are actually touching this technology underneath, where the piece that you see is the final analytical insight, the recommendation, the suggestion to you, the next step that you're going to take. And what happens underneath is there's a lot of data that's been processed and various different models that have been run over it in order to find that recommendation and then integrate it into that application that's serving out the results. And eye chart, but when I break down underneath that box diagram, what are the components that exist there? These are a lot of the things that are sort of in that expanded Hadoop world that's in Apache today, which is it started with the ability to store data across this distributed file system called the Hadoop file system. And then it moved on to this batch processing of MapReduce. And from there are so many more things that are in that ecosystem today. That ability to do SQL on top of that same kind of data, that ability to do stream processing on top of that same type of data, the ability to serve those results that you find out through many, many different types of interfaces and APIs and applications. So all of those different sets of tools that used to exist separately have now come together in one ecosystem that enable you to have a much more end-to-end flow with respect to how you process and ingest and manage data, how you're innovative around exploring it, and how you're able to serve out the results. So the other thing too is, when we used to first talk about this technology of the Hadoop world, the Apache world and all that, it's kind of like, it's open source. Open source brings with it some great benefits of the more eyeballs on the code, then, it's sort of been proven that the less security and vulnerabilities there are. So you have all of those benefits of open source. But on top of that, you now have enterprises like Cloudera and others that are wrapping up that open source and ensuring that it is available at enterprise grade. When I was with Nokia, we initially used to get our Hadoop version by just downloading it from Apache. And we sort of got to this point where we're like, well, we have enough Nokia business problems to solve that we probably should look to a vendor to help us get that software that we're running. So that's when we sort of moved over to Cloudera. Now, what are people doing with this? I showed you a few examples up front. And I've seen, as I've gone around the world and talked to folks in countries all over the place and in industries that span everywhere from financial services to public sector, to health and life sciences, to telecommunications and so on. What people are doing really breaks down into three categories. And I always call these the strategic initiatives. And this is one of the key things that we get our customers to do is to think about those strategic initiatives. One is almost every business or government agency needs to understand their customers or their constituents much better. So that age-old concept of a customer 360 and the age-old concept of needing to understand churn are still some of the number one things that people are doing with larger sets of data and machine learning these days. So the very first area of strategic initiatives is around growing your business, growing your customer base, understanding your customers better so that you can serve them better and have better relationships. And the second big piece is around connecting products and services. So I think anybody that's kind of been around for a while has built products over the years that, once it ships and it's over in the hands of someone else. And that is absolutely not the case anymore. And if it is the case, then you're losing a great opportunity. We all, I think, in our lives almost expect that everything that we use is somehow connected so that there's some way that it's improving itself over time and it's improving my experience with over the time. Whether it's your washing machine or your refrigerator or your car. And the key one is just your phone. We wake up on I always like to ask this question. How many people here sleep with their mobile phones? Okay, then I was following with, How many of you are lying? Okay, and then usually people say, well, how close does it have to count for me to be sleeping with it? How about within arm's length? How many of you sleep with your mobile phone within arm's length? Yeah, and so why do we do that? We do that because of the data and the insights that it gives us. Before you even get out of bed in the morning, you can check to see what the weather is going to be like. You can check the traffic. What's it going to be like to get to the Boston Convention Center? Do I have to get up now, or can I hit snooze a few more times? You can check the news just to see what happened overnight to make sure you really want to get out of bed. So that is all enabled by data and analytics, and there's an awful lot of data and analytics and machine learning that's happening underneath that experience we get from that mobile phone, which has replaced so many other things in our lives and sits right at the end of our arm. The third area is just around protecting business. Also, Cindy talked about GDPR. GDPR is a key regulatory compliance coming out of the EU, but we all need to comply to it no matter where we are, because for the most part, we all have customers that are in the EU. And it's, quite frankly, sort of good practice anyways. Understanding who are all those people that you're contacting, why are you contacting them, letting them opt out of that contact and say, forget who I am. That requires you to manage data in new and different ways. And quite frankly, we're using machine learning algorithms at Cloudera to manage our GDPR efforts, to go through all the rest of our systems as we bring the data together to figure out who are those contacts and at what point in time do those contacts need to be forgotten, and so that we can actually manage all of that data. And then also cybersecurity clearly fits in that space. A lot of the legacy cybersecurity systems are rules-based. Rules are all based upon what you've learned in the past. Machine learning is about figuring out something from the data that you didn't know and started applying that to identify anomalies that are happening now and could potentially happen in the future. So there's a lot that's happening in that space of compliance and cybersecurity. So we've already seen, we've got 850 customers that are using Impala Spark, which is an Apache-based module that we ship with our distribution, but is available through Apache. A ton of people that are using Spark to do machine learning. And at the same time, a lot of folks in the same system against the same set of data using Apache Impala to do SQL-based things. So you no longer have to have this bifurcated world where sort of structured data and SQL kind of BI things sit here and machine learning things sit here. Now we're seeing machine learning creating structured data that's served out through SQL and BI tools. And we're seeing structured data feed itself into machine learning algorithms. So it's becoming important for all those analytical algorithms to come together for us to be able to take advantage of the best of all those worlds. And then just a quick thing, I mean, if you don't believe me, there are people across all these industries that are using their data in this ways with these multiple different engines to manage their business across growing their customer base, connecting their products, and managing their risk. So I want to get to this secret sauce thing. We sort of talked about the why, and we talked about the how you go about doing this. There's this new and differentiated technology that lets you use data and manage data in various different ways. Now it gets down to this hard part of how do you get your people to organize in order to be successful? And I've always found that there's this one knothole that everybody has to get through. In a structured legacy database, you had to go find the data and know how it was going to be used and format a schema and put it in that schema. In this world of sort of big data, things that are based upon the premises of Hadoop and distributed computing, things that Google and Yahoo were at the forefront of, are around being able to gather data in its native format. And that means two things. First of all, it means it's easier for you to just capture data. You don't have to think about it and know how it's going to be used 1 year, 2 years, 3 years from now. You capture it in its native format, whether that is structured tables or whether that's text stuff or social data or video. You just can bring it all into this one set of technology in its native format. That blows the minds of a lot of people who have been database administrators for years. What do you mean I'm going to put it in there and I'm not sure how it's all going to be used? But that one change is what really changes a lot of how you need to change your culture and your organization to get the best benefit. So if you can't get through that knothole, and I've seen some of our customers run into this, where there's a set of people who say, I'm not going to bring that data in because you haven't told me exactly how it's all going to be used. It's like, well, the whole point is to bring it in so people can explore it. And granted, you've got to have the governance controls in place so they don't do anything bad with it or expose it in different ways that aren't appropriate. But you need to be able to explore lots of data in different ways and then hone in on the things that you want to actually put into production. So those lead to these 5 things that we've seen our most successful customers do. They are, in some ways, incredibly pragmatic. The first is to build a data-driven culture. The second is to obviously gather the right team and skills, and it's not necessarily the team and skills you currently have, but there are ways to sort of move people in that direction. We have found that in this world of machine learning and doing analytics in new ways, the agile development methodologies from the software world are the right methodologies to apply here. You want to be able to explore quickly. You want to be able to fail fast and move on. So all of those concepts of agile software development are perfect now to be applying to the data and analytics world. And then there's this sort of emerging concept of data ops related to DevOps, and I'll go into it just a tiny bit. And then the last piece I always say is right size your data governance, and I've alluded to this slightly. No longer do we have a case where you build a huge run book of everything, all the data and everything that can be done with the data before you ever let anybody do anything with the data. I'll show you a little bit about that too. It's a little bit more of a concept of being iterative in nature. So sort of right-sizing your data governance to the needs of your business at that point in time. So I was going to put pictures of my actual colleagues from Cloudera here, but I kind of thought these guys were cuter. So I went with these. Everything I'm going to say here, every one of those 5 best practices requires a stronger relationship with business and technical than we've ever had in the past. I've been in IT for a long time. We always talk about the business people and the technical people need to be hand in hand. And we don't always really get there. This is an absolute requirement for this to be successful. So the first is building a big data culture. There are some things that you can do that make it a little bit easier to get people to start thinking about data in new and different ways. One of my favorites is visualizations. So I put a little one up in the left-hand corner. It's not colorful enough, but I always tell my team, if you can make it colorful and move, you get extra credit. In some ways, it doesn't even matter what the visualization is showing. If you visualize some of your insights, it gets the interest of other people in the business. They might not understand the visualization, but they look at it and they go, I guess we have data, and I guess we have methodologies to analyze that data, and I guess we have tools to visualize it. So, and just that alone can get people to start really thinking about your business in different ways. At Nokia, we actually put monitors in the lobbies of some of our key buildings with some of these visualizations so that when employees and customers walked through, they'd go, this must be a data-driven company. Look at that stuff that's going on there. I've done whole meetings where no PowerPoints, no Google Slides, no nothing like that, just visualizations. Here's the insight we found. Here's what you can see from that insight. Here's the impact to the business. The second one is the key role of the executive sponsor. It more so now than ever in the past, because of this concept that I talked about earlier of collecting data in its native format, there's a tiny, tiny bit of the if you build it, they will come. Not a huge amount because this is iterative, but you've got to have an executive sponsor that gets that you want to find differentiated data for your business and you want to bring it together and you want to have people explore it. You'll have a hypothesis as to what they might find, but they might fail fast and find something else. And that's where it's really important to have an executive sponsor that wants to change. And I'll have to tell you, I often say to our account teams when they're out talking to customers, if your executive sponsor sort of checked out like, I'm retiring in 9 months kind of thing, which that would be really cool, but not in the cards for me. But if you're running into someone like that and they're not ready to change, then they're not going to go down this path to do things differently with data. So the executive sponsor is really key. And also enabling that executive sponsor is key. And one of the greatest ways to enable executive sponsor is to give them visualizations. What do execs like? Visualizations. And then they'll be able to take those and use them and show their colleagues that to get other people to understand what's happening. Another interesting concept is, the meetup concept's been around for, I think, almost 2 decades now, and Howard Dean was able to use it to successfully have a political campaign that was really more grassroots. So the concept of a meetup is more grassroots. So I have found, both back in my experience at Nokia and in my experiences with other companies around the world, that instead of doing project reviews on what's happening in data and analytics, bringing together the community of people that are working on it and letting them be the ones that are up in the front of the room showcasing what they've built and what they've found is really powerful. It's so much more powerful than having a director or a VP stand in front saying, we found this, we did this, where then everybody glazes over. But if it's a data scientist working with a data engineer and they're in the front of the room and they get really excited about this and they're showing their peers. So we now do these at Cloudera on a monthly basis. We have a globally distributed team. So we do it in a way that there's some people on different sites that video in and people who are in their home offices that video in. And all different people volunteer on a monthly basis to showcase their stuff. The biggest key to the success of a meetup at any point in time is that pizza. When you're doing a global one, we haven't cracked that. We've been thinking about shipping coupons to people, but we haven't actually cracked how to get pizza to people's homes. But the meetup is really, really an amazing success factor for starting to drive towards this community concept. So I'm going to hit team and skills a little bit. Let me just go on to this one. So the first 2 major roles are the data steward over on the business side and the data engineer on the technical side. On the business side, you've got someone who sort of understands the data, how it's collected and how it's used from a business's perspective. They might not know the ins and outs of all the different data, but there's got to be a data steward. Yes, I own that data at source. I own that business process. I understand why salespeople are behaving this way and why our financials behave that way. And then they work on the technical side with the data engineer who's responsible for ingesting and cleansing data and building data pipelines so that that data is readily available for people to use. Those are the first 2 key roles. And then the second 2 roles that we talk about a lot, I product owner in the agile sense of the world, but really it's a subject matter expert and a leader on the business side. Somebody who says, I know what we're trying to accomplish here, and I'm going to work with this team continually to make sure that we're focused on accomplishing that if we need to change up the requirements, we're changing up the requirements. And that person matches up to the data scientist, the infamous data scientist, who often, except for my daughter, doesn't really exist. What I've found in this world is that person who has did you say Drew Conway's speaking here later, or the Drew Conway diagram? Yeah, the Venn diagram. Love that Venn diagram. I don't know, you guys probably know the Venn diagram, but it's got somebody who has the perfect blend of hacking skills, which is a complement. Hacking skills means the ability to go through and move from tool to tool really quickly. The perfect blend of sort of really broad and deep statistical knowledge and the really deep subject matter expertise in your business. Now, if you look at a financial services business or a Komatsu's business with trucks, equipment, it takes decades to get subject matter expertise into a business. And to have really broad and deep statistical knowledge, particularly when you're starting to think about some of these new methodologies around neural networks and deep learning, that's a whole skill in itself. And then the ability to really code, and code quickly, and code at a high quality, those models that people are coming up with. I have found for the most part that you take 3 people and you put them together, and that's how you actually get your data scientists. Incredibly effective. We do this at Cloudera all the time. I've seen this done in many, many companies around the world. I'll fill this out with a couple other roles. You obviously need those data analysts who sit out in the business, who are going to be taking some of the results that are coming from data science. And then you do occasionally find that person that can span that boundary between the business and the technical side to do some more of that data science work. When I see this happen in most businesses, and this goes from companies our size, and we're like 1,700 employees, to companies that are very large, so very large manufacturers and very large consumer products companies, have core teams of data engineers that are working on building out that data asset for everyone to use, core teams of data scientists, whether it's the one person or the three people together, centrally, and they're building models at scale. But then out in the business units, we see people who have data scientists and analysts out in the various different business units who are doing quick exploration of data to find insights that could be used by a business unit. And then when those insights are actually found and found to be really worthwhile, usually they come back into that core team of data scientists who can help to bring those models to scale and help to bring them to production. So Agile for development, I'm sure you guys are all familiar with it. I just always go back to, website development, those same principles. People really get it. You weren't going to put up a website and then put up the next version of it a year later. You had to have this continuous type delivery. And we really need to get to continuous type of delivery for analytical applications as well. So we're seeing the same principles of Agile apply to data and analytics and machine learning and AI types of projects as we saw in typical software development, whether it was website development or app development. And those same people that I talked about on the prior slide are the people that are now participating on these teams. So you'll have data scientists, data engineers, and then app developers themselves who might be delivering the actual product out on these teams. And then data ops for production. So data ops is a lot like in the Agile world, you have DevOps. So you have this world of being agile in development and getting things done really quickly. And then on the IT side, you've got people who are really constrained by having to have very reliable, scalable systems. So those two things are really at odds with each other. Back in the 90s, when we started doing this for website development, you inserted a set of people who had that mindset, sort of that dual mindset of I get what development's doing, but I get what IT needs. And then it moved on to a bunch of tools that exist in that space to allow that continuous test and deployment as you put new things into this world. In the case of data and analytical applications, it's really exactly the same, except that there's this added component of really needing to be able to measure those data pipelines and make sure that the data is flowing from source into wherever it is it's being processed, that you understand there aren't duplicate records, there isn't something missing, and then the way that it's actually analyzed, the whole lineage of that, and then how it actually gets to production. So starting to really put some control process monitoring around the data pipelines themselves to ensure that what you see in production really is of the quality that you need. And finally, the last is data governance, and a couple of just concepts on data governance. So as I mentioned, instead of the big, huge run book up front, we've implemented in lots of customers around the world sort of a very lightweight data governance model that will continue to get stronger and stronger over time. But the first thing is, a lot of people can explore this data quickly. What I found is you'll get 10 different people showing up in a meeting with some sort of different insight about the same sort of metric, and the number's different. And that's because you let a whole bunch of people explore stuff and they thought, wow, I came up with something cool. But they might not really understand the business logic. So a quick way to do this is to just, first of all, get a business owner of the definition, do a good documentation of what are the sources that go into building out that metric or that measurement that you're looking for. Define the analytical methods. So we actually do a really simple one-pager at Cloudera with our different business metrics, and what is the analytical methodology that we use to produce the result from those data sources. And then the really key thing here is back to the old RACI diagram, who is responsible, accountable, consulted, and informed on what that metric is so that they understand when they're looking at it where it came from. A couple other little things here. Also, when it comes to data governance, another way to think about it, sort of in this world, you're ingesting data and it's very raw in form. You have people exploring it and innovating, but you set up your environment so that they can't get things to production. They're really in sort of that sandboxy exploration world. But then when you actually end up operationalizing and integrating with final applications, that's where your governance needs to get fairly high. So it gives you, it's an inside-out view of data governance than what it's been in the traditional data warehousing world. So I'm going to close with that. It's just, I think kind of our recipe for success has been a bunch of different things. We're all based upon open source innovation. Security and governance is really tremendously important. The ability to do machine learning and all sorts of different analytics in the same platform will give you a lot more options as to how you go. The deployment methodologies in cloud or on-prem, there's just so much choice these days. And then finally, we at Cloudera, we build the platform, that's based upon those Apache Hadoop technologies, but it's really an ecosystem of a lot of different folks in the IT space that provide a lot of the open source tooling for machine learning, a lot of the desktop type tooling, and a lot of the BI tooling that sits on top of it. So with that, I want to thank you.